Hello, my name is Dr. John Liu, and I'm a lecturer and scientist at MIT in the Mechanical Engineering Department. I lead a group at MIT that aims to scale engineering education and training to better meet the increasing demand for STEM skills in tomorrow's workforce. And today I'm sharing some current work that my group is doing to develop augmented learning experiences that meet manufacturing training needs. First, we're facing a nationwide skills gap on the order of 2 to 3 million people in the next decade. And if you take a look at, or if you walk into any lab or machine shop, you'll see that the cohort, the student to instructor ratios are quite small. And that's because the great deal of attention that each instructor needs to spend on each student. And so if you think about the training system nationwide as one entire system, the bottleneck is the instructor. Second, go into any machine shop and you'll find that it's often not the people that are idle, but the machines that are idle. And third, we're facing a fundamental barrier in the ways that skills are being transferred because currently they're person to person. Then the new know-how is really limited in a region by the rate of person to person skills transfer. And this is even more acute if you live in a rural area that struggle to recruit trainers, but still need to rapidly upskill to adapt to advanced technology. And finally, a lot of our age force is retiring, and companies vary very much with training. And so, what will happen when they retire? Where will all of that knowledge go? So imagine instead if we could create digital experiences to learn manufacturing that scale to teach many more people, are still hands-on, and could start that hands-on learning before you even get to school, get to campus, or get to the shop. And we could better use instructor time for the interactive parts of learning. And so here's an example of a virtual model that could appear in your dorm room or apartment room, and there would be an enhanced and narrated introduction. So a virtual model appears through augmented reality, whether through your tablet, your smartphone, or a dedicated HoloLens or augmented reality headset. And we would have a narrated introduction on the different parts. For example, this is a milling machine adapted from our machine shop at MIT. There would be the functions and operations of each machine element as if an instructor were with you introducing the different parts. But instead of pausing the entire class every single time you missed a point or you have a question, you could actually pause and replay. Or if you know a part, you could actually skip that explanation and move to the next place. And then imagine you're still at home and you begin to start practicing basic functions at home, like drilling or facing, edge finding, how to lubricate your part, except you're doing it all in the virtual world. And this experience would take you step by step, as shown here in the screenshot. Now, a lot of first-time machining students, perhaps some of them who are watching this talk now, are afraid of making mistakes. Maybe to break, you're afraid you'll break the machine, you'll chip a tool, or you'll hurt yourself or someone else. And so why not make all the mistakes here first? Don't touch the spindle, stand here. Did you tie up your hair? Have you applied enough lubricant? These kinds of mistakes that first-time learners are especially afraid to make. You can make it all in the virtual space when it's cost-free and risk-free to make. And perhaps afterwards, there's a summary of the mistakes that you made to recommend different parts in the module that you should repeat or practice more until you're confident. So then you go into the actual machine shop. You've done the things in the dorm room, and now you're into the machine shop. This is just a screenplay, a capture of what is on our tablet. This is an actual machine shop at MIT. And notice how there's an interactive CAD now that's overlaid over the actual milling machine. And we could orient ourselves to the actual milling part, the milling machine, and to see, oh, this is how a vise works actually in your 3D physical space. The part comes down, the vise comes over, and you might want to replay that animation if you didn't catch it the first time. And because it's student guided, it's according to your time, you can determine what you like. And you might have questions about different parts in the milling machine. And so at this point, you could actually look at, oh, I want to just focus on the spindle. Or sometimes I might want to look at the controller or the table. I might have questions about particular parts around the table, for example. And so I could go into a large database and browse the frequently asked questions around different parts and functions of that machine. And so this is a mixture of both the physical context, the milling machine, and also, of course, the virtual element of augmented reality. And if I'm, for example, curious on how to switch a tool, then I could play a video according to the question that I have. Now, when we start out learning machining, we often do go through a tutorial of different steps of making a very simple part. And so we're also currently creating a workflow of basic tutorials where now the text and pictures are overlaid on your side view or in a tablet instead of having to go all the way from paper instructions to what you're machining. If you're wearing, for example, an augmented reality headset, all of the instructions would then be streamlined into your workflow. And so here's a student in my group, Gabrielle Enns, introducing how the tutorial app works.
You'll start off on the home page, and it gives you an option to just start the AR experience, which is what's happening here. And you can see this is like an actual camera view of your table, and you can tap the horizontal surface to place a 3D model in the space, which is pretty cool. And then in the top left, there's like a FAQ button for available gestures. And so you can see the different gestures you can do to manipulate the model to make it have better visibility. So you can like scale in and out, which we'll show in a second. But yeah, you can scale in and out, have a better look at the model, translate it into space, even rotate it. The bottom left, you can see we've toggled the section view. So you can turn the piece of stock into a section view. You can toggle the dimensions on and off, so to like clear the space. The bottom center has like a chunk of instructions, which is something we're toying with. The instructions are basically for each of the steps. It'll tell you what to do. And you can use the top right arrows to step through the whole process. So right now we're on milling steps. And so as the student completes one step and understands what to do, they can just move on with the rest of the procedure. So now we're on assembly. All the pieces have been completed, and it really comes to like actually putting the flashlight all together. So this is just an exploded view. And you can use the slider at the bottom to step through each of the parts, and the pieces will kind of snap into place. But if the student actually wants to see everything slide into place, they'll use the play button in the top right corner, and that'll just slide the pieces right into place. And this is what we kind of want the milling and the lathe steps to look like in terms of animations, and having a drill come in and out of a part, or the piece of stock turn on a lathe. We really want to have that visual aspect of it so that the students can see what it's like being in a machine shop without actually having to be in a machine shop.
So these are some of the experiences we're developing for learning machining. I want to share another experience we're developing. At MIT, a lot of our classroom time is focused on learning manufacturing by simply disassembling actual manufactured products. Things like a children's toy, pipe fittings, or even cut up portions of an electronics tablet. But two problems remain with this kind of thing. Well, one is that if we're interested in a particular product, it might not always be available for students due to issues of availability, size, maybe it's too big, safety, distance, or cost. So for example, what if we wanted to carry out this kind of learning activity for a radioactive part in a nuclear reactor or a MacBook Pro? We certainly can't afford that for every student. Or in contexts like this, which is common in COVID, which is remote kinds of learning. This kind of learning is also great if you're in person at a place like MIT, but there's also a lot of other kinds of contexts where you might not always have access to in-person experiences. And secondly, there's a complex multi-stage thought process between examining a product and really creating deductions on manufacturing processes and decisions, from noticing, assigning relevance, assigning meaning, and deduction and analysis. And that's not very well understood. So we're interested in teaching that kind of process methodically and structured. We're making an app where you can disassemble manufactured products in augmented reality, in the virtual space. So here, and other than the text that appears occasionally, there's no post-editing of any video. This is simply a screen capture of our app. And you can tell that the fidelity, the visual fidelity of these parts make it almost seem like they're real and they're right in front of you, except that you can actually click them and interact with them in the virtual space. So the app displays life-sized components. It's grounded in fixed space, and then you can actually inspect a particular part. And we might be interested, for example, in looking at those milling marks that appear in the inside of the back housing that you see here. Or if you want more hints on what instructors or what manufacturing experts think is relevant to the manufacturing of this particular part, then there are hints that we would provide through these yellow boxes. So we want to address the instructor bottleneck by scaling. We want, through self-directed learning in AR, to be able to maximize the learning time on current equipment in schools and companies. And with a digital solution, we can scale and disseminate to meet a larger workforce, those needs that we see on the nationwide scale. And finally, we can capture the best types of knowledge in the industry and optimize for the best way to learn. I hope you enjoyed the session. We are from mechanical engineering at MIT, and best of luck to you in your career.